Bismillahirrahmanirrahim. Obtain h of t if h of s is equal to 20 over s plus 3 into s square plus 8s plus 25. So we need to find out the inverse Laplace transform of given this h of s to obtain h of t. So in the denominator we have the simple pole s plus 3 and this quadratic term. So first of all, let us resolve this quadratic term. Find out the poles for this quadratic term. So let s square plus 8s plus 25 is equal to 0. And then using the quadratic formula, s is equal to minus b, which is minus 8 plus minus b square, this is 64, minus 4ac, that is minus 4 into 1 into 25, that is 100. So divided by 2a. So as we can see, this results in complex poles, complex conjugate pair of poles. So this is minus 8 plus minus 64 minus 100 is minus 36, right? And this will be j6, right? 36 square root is 6, j6 divided by 2, so that is minus 4 plus minus j3. So we have a complex conjugate pair of poles, right? So we can employ partial fractions to obtain to simplify this term and then find out the inverse Laplace transform. So h of s is equal to a is equal to 20 over s plus 3 s square plus 8s plus 25, and this is equal to, we assume, a over s plus 3 plus, because this is the quadratic term with complex poles, we write it like this, bs plus c, right, divided by s square plus 8s plus 25. So now if we multiply both sides by s plus 3, so that will be h of s multiplied by s plus 3, right, and this will result in 20 over s square plus 8s plus 25, and this will result in a, because as we multiply this with s plus 3, so this will result in simply a plus bs plus c into s plus 3 over s square plus 8s plus 25. Now if we let s plus 3 is equal to 0, that is s is equal to minus 3, and if we substitute this here, we will get a, right? So because when we substitute s plus 3 is equal to 0 or s is equal to minus 3, so this term will get eliminated. We are left only with a here, right? And when we put s is equal to minus 3 here, we will get the value of a. So a is equal to h of s substituted with as h of s into s plus 3 substituted with s is equal to minus 3, and this is equal to 20 over 3 squared minus 3 squared is 9, right, and 8 multiplied by minus 3 is minus 24, and this is plus 25. So that is 25 minus 24 is 1 plus 9 10. So this is 20 over 10. So So A is equal to 2, right? So we have found out the value of A. Now to find out the value of B, we can proceed in many ways. So one of them is to suppose take an arbitrary value of S. So let S is equal to 0, right? Let's call this equation number 1 for sake of reference. Let S of 0 in this equation 1. So if we put S is equal to 0 here, so we'll get 20 over, this is 0 plus 3 into 0 plus 0 plus 25, and that will be equal to A over 3 plus BS. This will be reduced to 0 and we're left with only with C over 0 0, and this is 25. We're left with 25. So this is 20 over 75 is equal to A over 3 plus C over 25. So let's substitute the value of A also here and multiply it throughout with 75. So that will be 20 is equal to this will be 25. 3 multiplied by 75 divided by 3 is 25, and the value of A is 2, and this is 75 divided by 25 is 3C, right? So we have 20 is equal to 50 plus 3C, right? So we're left with 3C is equal to 20 minus 50, that is minus 30. So C is equal to minus 30 over 3, that is minus 10. So we have found out the value of C as well, right? So we can now put S is equal to 1 in 1. So let S is equal to 1 in 1, so that that this term is not reduced to 0 now, because S is equal to, we have substituted S equal to 1, and we can then put in the values of A and C to find out the value of B also when S is substituted as 1. So when S is substituted as 1, this becomes 20 over, this is 1 plus 3 is 4, and 1 plus 8 plus 25. So this is 25 into 26 and 34, right? And this is equal to A over S plus 1 plus 3, that is 4, and that is B plus C over this is 1 plus 1, and this is 34 again, right? So this is 20 over 4 into 34, and that is equal to A over 4, and that is B minus 10 here, because C has value 10, right? So that is B minus 10 over 34. So let's multiply throughout with this term 34 multiplied by 4. That will be easier for us. So that is 20 is equal to A into 34, and this is B minus 10 into 4. So the value of A is 2, so that is a 68. So that is 20 is equal to 68 plus 4B minus 40. So 4B is equal to 20 plus 20 plus 40 and minus 68. So 4b is 60 minus 68, that is minus 8. So this gives us b is equal to minus 8 over 4, that is minus 2. So we have determined all the three coefficients, right? So we can now write down this transform in expanded form by substituting the values a, b, c here, right? So h of s becomes, the value of a was 2, so 2 over s plus 3, and the value of b is minus 2, so minus 2s, and c is minus 10 over s square plus 8s plus 25. So now it is easier to find out the inverse Laplace transform of both these ratios fractions, and with that we will be able to find the inverse Laplace transform of h of s. So first we need to write this in a form so that we can find out the inverse Laplace transform for this term. The inverse Laplace transform for this term is easier. So we know that the Laplace transform of e of t is equal to 1 over s plus a. So the Laplace transform will be 2 e raised power minus 3t, but this term is somewhat difficult to figure out. So we will show how to find out the inverse Laplace transform for this term. So let's write it, and we take this 2 common, so this is minus 2, so we leave with s plus 5 divided by s square plus 8s plus 25. So this s square plus 8s plus 25, let's see this, s square plus 8s plus 25, it can be written by completing the square something like this, s square plus 2 into 4s, right? And this 4s, this 2 term, and this 4s, this 4 squared, this will give us a squared term, right? And this is 16, and but we need to have a 25 here, so left with a 9 here. So this can be written as s plus 4 squared plus 3 squared, right? So let's rewrite this term using this one now. So h of s is equal to 2 over s plus 3, 2 over s plus 3 here, right? And minus 2 s plus 5 divided by this term. Yeah, we replace this with this one, right? So with this term, so this is s plus 4 squared plus 3 squared. So we know that if we have s plus 4 here, then this will be the Laplace, the transform of e raised power minus 4t cos 3t, right? So because we know that the Laplace transform of, for example, e raised power minus at cos omega t is given by s plus a divided by s plus a squared plus omega squared. So if we have term 4 here, so this will be the Laplace transform of e raised to the power minus 4t and cos 3t, right? So let's rewrite this. So h of s is equal to 2 over s plus 3 minus 2, so this is s plus 4 plus 1, so s plus 4 squared plus 3 squared. So h of s is equal to 2 over s plus 3 minus 2 s plus 4 over s plus 4 squared plus 3 squared, and this minus 2 here with 1 over s plus 4 squared plus 3 squared, right? And now h of s is equal to 2 over s plus 3 minus 2 into s plus 4 over s plus 4 squared plus 3 squared. And now if we have 3 here, which we had 3 here, and this will be the Laplace transform of e raised power minus at sine omega t. So what we do is we multiply it with 3 and divide it with by 3. So this is minus 2 over 3 and 3 here, s plus 4 squared plus 3 squared. So this is the Laplace transform of e raised power minus 4t cos 3t, and this is the Laplace transform of e raised power minus 4t sine 3t. So using the inverse Laplace transform, right? So the h of t is given by this is the inverse Laplace transform for this is 2 e raised power minus 3t, and for this is 2 e raised power minus 4t and cos 3t, right? And for this it is minus 2 over 3, and this is sine 3t, right? And we enclose whole of this term with u of t here, and we e raised power minus 4t here also, right? E raised power minus 4t sine 3t. So we can take this 2 term common, right? So h of t is given by 2 e raised power minus 3t and we take this minus sign common, and e raised power minus 4t common here, and we can write it 2 cos 3t minus 2 over 3 sine 3t, and enclose whole this with u of t. And this term, which involves both cos and sine terms, it can be combined in the form of, for example, r cos 3t minus theta. So r here will be equal to 2 squared plus 2 over 3 squared square root. So that will be 4 plus 4 over 9 squared, that will be 36 over 9 plus 4 over 9, that will be 40 over 9 squared. So that will be r is equal to 4 into 10, so this is 2 over 3 square root 10, right? So square root of 10 multiplied by 2 divided by 3 is given by 2.108, right? 2.108. And theta is equal to tan inverse 2 over 3 divided by 2, and this is plus sign here, right? We take the negative e raised power minus 4t common here, so 2 over 3 over 2, so we're left with tan inverse 1 over 3. So theta is tan inverse 1 divided by 3, so that is 18.43 degrees. 18.43 degrees. So we can write it h of t is equal to 2 e raised power minus 3t, and we can write here minus 2.108 e raised power minus 4t, right, and cos 3t minus 18.43 degrees, and we enclose this term here with u of t, right? So this is the inverse Laplace transform of the given function here, h of s, of the given transform h of s. So this is the inverse Laplace transform of this function. H of t is equal to 2 e raised power minus 3t minus 2.108 e raised power minus 4t cos 3t minus 18.43 degrees. And we could have taken 2 common here and then found out the coefficient and the theta, and we could have arrived at the same result, because coefficient 2 when multiplied with the resultant coefficient will result, and this 1 over 3 here with 1 here will result in the same value here, right? So this gives us the inverse Laplace transform of the given function.